Good evening, guys. Thank you very much for gathering here. It's a pleasure to be here today and to present the topic of AI. Thank you very much for inviting me for this talk as well. So AI has been a kind of buzzword that we all have heard for at least several years, but it's becoming more and more popular. So I think I chose this topic because I think as an industry and as technologies of this country, we need to invest more in AI and build our applications and inject AI into various aspects of our applications. So I'm VP of engineering for Sysco Labs. So I've been there with Sysco Labs for about 12 years, one of the starting founding members as well. So my expertise is in building applications, especially in restaurant industry and food services industry. So we build many products and we are enjoying it every day at Sysco Labs. And we are also planning to use a lot of AI-based solutions in our product suites in years to come. So I'm not an expert in AI, but I've been experimenting with some of the AI concepts and how it can be applied to our day-to-day lives and day-to-day product development. So I'm going to share that knowledge with all of you. Topic I chosen was embracing AI. Actually, like in the meetup description, I was trying to see what is the topic that I'm going to choose. So embracing AI, I thought was the best topic because as technologists, we need to embrace AI because that's going to be the future. And as general public also will have to face the impact of AI. So my topic is broken down in two sections in presentation. In the first section, I want to give an introduction to AI because I believe in a meetup like this, rather than just hearing some buzzword, I also want to give out something so that you can build upon that after the meetup. So that's why I included some introduction to AI. Some of you may already have started building AI-based applications, so we can make a discussion around those as well. So it will be about 20 minutes session on building an example AI solution very quickly. Then I'll go into discuss about how AI is affecting our society and what are the challenges in future, as well as benefit we will get by applying AI into our day-to-day applications. So quick introduction. So when you talk about AI, you probably hear AI, ML, machine learning, and deep learning. It's very confusing what these concepts are. AI is kind of the broader concept of teaching machines to learn from data. So it's a huge subject that has been there for years. So machine learning is one way to achieve that, right? Machine learning is like machines are able to learn from a lot of data, and they can run a lot of complicated algorithms and complex calculations, statistical calculations. So that concept of machines being able to learn from data is generally called the machine learning. Then you get to the deep learning. Like if you hear a lot of these solutions, they talk about, okay, we are using deep learning. So deep learning is actually one kind of an algorithm to build machine learning, and it is called a neural network. So deep learning is the most popular way of achieving or building AI solutions nowadays. So that's the kind of simple relationship between these few terms. So typically when we program, what we usually do is we build an algorithm, right? So we know what sort of data we have, and then we code the algorithm so we know the exact output. So we as programmers or engineers, we build that algorithm. It could be very sophisticated algorithm, but they are primarily rule-based. So in AI, the difference is we don't figure out the algorithm. We let the computer figure out the algorithm, right? So that's the difference. We tell, okay, this is the data you have, and this is the outcome we have seen. Can you figure out the relationship between that data and the outcome? Right? So the computer has to figure out what is that relationship. In order to instruct computer how to build that relationship, we have certain algorithms. but actual algorithm of identifying the relationship between data and the outcome is built by the computer. That's why we call computers can learn. They define what is the relationship between two. So I would also like if you can ask few questions so that my talk is not so boring. If you have any experience around this, and if you can, help me drive this presentation, because it will take about 1 hour. I want to make sure it's very active as well. So any typical AI model has 3 main steps, and you need to understand this, because whenever you build an AI-based solution, you will have to go through these steps. So one of the most challenging steps is identifying the data, right? Why is it so challenging? Nowadays you hear, okay, we have access to a lot of data, right? We do have. We get access to a lot of data from all sort of sources, from social networks, from our databases, data archivals, and maybe hard copies. Everywhere we can find data. But the biggest challenge we don't probably know is what is the relationship between that data and a particular outcome, right? For example, if you want to price an item, how should that price be affected by the attributes of data that govern that pricing in a competitive market, right? So that's where we need to spend a lot of time before jumping into even technical details. So just by being technologists or learning AI and algorithms will not help you if you don't understand the business. And it's very critical. We all become kind of business engineers, right? Because without that deep understanding of the business, you can't relate. You can't relate how a certain behavior is affected by what is surrounding it, right? So first step I would say is identifying those attributes that contribute to a given outcome. Then of course, okay, I didn't see these small boxes there. I don't know how it came here. Maybe I had an online version. Now this is the local version of PPT. Probably I'm seeing it. Okay, the second step is choosing the right algorithm. Once you have identified those data points, then you can actually choose a kind of algorithm. I'll quickly go through some of the algorithms as well. These you don't have to learn from scratch, but these algorithms are there, right? You just have to build on top of those. And I don't think, unless you are a good scientist or a mathematicians, it'll be easy to come up with a better algorithm. You need to have a very sound mathematical background in order to come up with those algorithms. But of course, you can find some similar algorithms for your problem. The third step, and also processing power. I think I wanted to talk about this because I think the only change that has made AI this popular is the processing power that we have. Otherwise, these subjects have been there in academia for years and years. With the increase in processing power, because if you will understand, to train this model, it takes a lot of time, because we are talking about millions of data points, and sometimes even a small problem you will see, okay, it takes too long to train, right? So processing power is really important, and you need to figure out, and that's why I think instead of CPUs, now we are going into GPUs, and also like Google has invented what we call TPUs, tensor processing units, right, which are made specifically for AI-based processing, because processing power is extremely important for any successful AI solution. Third step is, once you, with the right algorithm, you can train the model, and I'll quickly go through some of the examples. So if you are new to AI, you will grab something from there, right? And could you tell me, like, anyone who has worked on any AI solutions, so that I know kind of the background? Anyone who has used AI based services? What is the service you have used? Sorry? Azure machine learning, okay. Anyone who has used AI based products? I'm surprised. I think all of you have used a lot of AI-based products today. If you are using Gmail, Gmail has a lot of AI concepts in it, right? You may have used Smart Reply, and there is another concept called Smart Compose, which allows you to compose a mail without even type in a single word, like it can build. Smart Replies, you may have seen, like when you get an email, it gives you about 3 buttons: thank you, noted. Those decisions are being made through AI, right? Google Search, Google News. There are a lot of applications, we use them even without knowing, right? So I think all of you have already used AI. Third step is deploying the trained model and iterating over that. No AI solution is mature enough at the early stages, because you will see we always do an approximation, right? The more data you have, you can make it better, right? So that's why I think Google has become so powerful out of all the other AI players. I think Google has the largest amount of data. So because of that, their solutions are, I personally believe, far more superior. If you look at their voice recognition. So Siri, I have never been able to get it to work for years. It cannot understand my accent, right? Maybe I can do few things with that. But Google, if you speak to a Google device today, it can understand exactly what I'm talking about. So it can understand various accents, the way it can correct also. And recently, it has never understood my speech mistake, even by a mistake. So it has become so advanced. So training your model is an important part of that. So you need to deploy these solutions, collect data, validate that with the ground truth, and again you can do the training. So those are the steps. So I'll actually take you through these steps so you will understand some of these concepts, because I'm sure you guys have heard a lot of these concepts. So that's why I added some practical examples as well. So these are the dominant frameworks for AI. I've been experimenting with several of them except Microsoft AI. Google TensorFlow is probably the most important one out of all of these, because actually they are the people who outsource their framework, and that probably sparked that entire ecosystem of AI, even with other players like AWS, even Microsoft. I think they followed that pattern. So Google TensorFlow is kind of a very low-level infrastructure for building artificial intelligence. There are certain attributes that you need to analyze when using a framework. If you want to really experiment about algorithms and tune them and see how algorithms works in very low level, maybe TensorFlow is a good library that you can use. Then Google has its own AI as a service, right? I mean, you may have already used voice recognition. There is an AI. It will recognize your voice and translate into text. IBM Watson is again another platform. That is again AI as a kind of service. AI as a service means they have pre-built solutions, right? But when you try to apply this into your day-to-day businesses, your scope is limited, because they can provide only a common set of services. For example, they can provide voice recognition, but your businesses, if you really want to use that, you can use as a feature. But if you think about how you can apply AI to improve your business outcome, probably some of these services are not that great, right? Sometimes you can just enhance your application to a certain level. That's why understanding AI is going to be important. I think someday you will have to learn AI. So just having these services will not be sufficient. Watson is again AI as a service, so you can do voice recognition, you can categorize topics in a document, and there are certain things you can classify some of the images as well. Microsoft I haven't used much, but they also have very similar services. Then AWS also is investing a lot in AI, and they have recognition, like it can recognize the face of you, and then it has legs, like it can do natural language processing. You can build a lot of bots. I mean, those cool features are there. But they internally use Google Google TensorFlow like libraries to build those solutions. So out of all these, what I'm going to use today is AWS, and there is a reason for that. One thing is I am more familiar with AWS, and also it provides the entire ecosystem of building an AI solution from scratch. TensorFlow, if you look at, is a library. You need to find out your processing power, how to do it. But AWS probably the most comprehensive framework that I've seen out of those. So it may be subjective, but I prefer to use this, and using this I can probably go through some examples. So entire infrastructure, like storing data, processing them, formatting them, then deploying them is a breeze with AWS. So I'll quickly take you to the example implementation. That will probably keep you more engaged with that as well. So I'm going to build a very standard solution, right? Because I can't figure out a different one. So you guys may have already seen some of these somewhere. I'm going to implement what we call identifying a handwritten digit. This is kind of the hello world program in AI, but it will teach you all the concepts. And we'll see the hello world of AI is not as easy as hello world of Java or JavaScript like languages, right? It takes a lot of effort. I'm quickly going to take you through so if you have any questions, okay, I'm going to build this solution, and it requires some time as well. Like you need to train it and deploy. It takes some time. During that time, I can take some questions as well. So I'll quickly go through this, and I expect some questions from you during the time that I have to spend training my model. So this is the tool I'm going to use. Have you guys used, there is an editor called Jupyter. Has any of you used this editor? You have used? Yeah, it's very powerful. I feel a very cool concept. Been using it for several months actually. This is an editor where you can code, you can process data, you can see the result, you can present it, you can do everything here. It's like a programming environment with the ability to present what you do as well. So the problem we're going to solve is classifying handwritten digits. So the first step in our AI solution is going to be identifying data attributes that contribute to your outcome, right? So here we need to identify what actually contributes to identifying a number as a particular digit, a specific digit, right? So if you analyze this, you can see each pixel has a light intensity, right? If you look at this is a grayscale picture, it has white and black and colors in between. So each pixel can represent a value. So that is the kind of attribute that actually contribute into identifying what this particular digit is, right? When I say that for this digit, it is easy to understand, but in your business scenarios, you need to identify how your price is going to be affected by various attributes of the data. Competition, maybe the past sales, customer preferences. You have to look at all those aspects, right? This is so simple. We just have to work with the digits. So this image, if you look at, is 28 by 28 pixels. So it has about 284 pixels in it. So the first step is preparation. So for this model, we're going to use 70,000 images to achieve a small outcome. So finding 70,000 handwritten digits is not easy, right? It takes a lot of time, and I'm sure any AI solution that you build will face similar challenges. And even big players like Google, I'm sure they have faced a lot of challenges getting this data, storing and processing it, right? And each image is 28 by 28 pixels, and each pixel represents the light intensity of that pixel. And in AI training, typically while you train, you also validate the accuracy. So you break down this data set into two sets. One is used to train your model, and a small set is used to validate your accuracy. So that's why this is broken down into two data sets. And just for you to understand about Jupyter as well, we can examine data in it. And this is also a typical part in any AI solutions. You need to experiment with data, see whether data is properly organized. So this piece of code will download the data set from this given URL. And here you can see data that, okay, so in this shell, okay, in this, let me see. I don't know whether I'm connected to internet. Looks like I'm not connected to internet. Let me double check my connectivity. So I didn't check my internet connectivity. I was hoping it will be available. Sorry? Okay, I do have. Okay, I think I may have to refresh this. Looks like I had to log into. Okay, I've been logged out of AWS. I'll actually take you through some of these steps during the training time. Okay, I'm back to this. So let me just examine this data and see whether it works. Yeah, it's working. So during this step, you can see like what is actually in this data set. Just for your knowledge, this data is organized in a way like you have a two-element array. The first array is an array of all the images. The second is an array of all the labels related to those images. Like in each array, you have like 70,000 images. And what are the corresponding labels for those images? Because we need to have data and the labels. We call them labels because we already know this is what it is, right? Based on that only we can train. And this is called actually supervised learning as well. I'll cover that in a while. So I am just showing a random item here. Maybe I need to see the fifth item. So I'm taking the fifth item of the first array and the fifth item of the label as well. So they need to match. So this data has been pre-processed. So in your solutions also you need to have them organized in a certain way. Actually it ultimately converts into numbers because all these AI algorithms work on numbers. So it doesn't actually work with the images, right? All these, even the labels are numbers because numbers are more efficient for processing, right? So any of these is getting actually converted into numbers. So I can execute, yeah, that is 2. Likewise, you can see various images, say 50th image, right? So likewise, we have 70,000 images, right? And you have to label them. For example, let's say you want to build a solution where you need to identify a tree. Given you take a picture of that tree or the leaf of one of the trees, you can identify what that tree and the history of that. Look at the amount of data that you need to collect, right? You need to have pictures probably of all sort of trees and train them. Unfortunately, that you have to do, right? So we know our data is pre-processed appropriately, then we can go into training. So second step is identifying the algorithm, right? There are two major types of algorithms. One is called supervised. In supervised, you have a data set as well as you know the classification of that individual data item, right? So with that, you know, like if you look at our problem of handwritten digits, you know the digit as well as what it is. Based on that, you train, right? So that is called supervised. You always have a data set and a known output as well, right? So under supervised learning, typically you get 3 different types of algorithms. One is binary classification. Like then again, a lot of these AI solutions are built based on the answer that you are expecting, right? So for example, if you expect a binary answer, then you probably choose an algorithm that can give you binary results. First one is this email is spam or not a spam. Just a binary answer you need, right? Will the customers buy this particular product or not? So it's binary. Always answer is yes or no. So that's called binary classification. For all of these sort of questions, we have pre-built algorithms, right? I mean, I'm sure you guys deal with a lot of products that require similar kind of processing, and definitely there are algorithms that you can use. So worry about the data, how to find data and pre-process them. Second type of algorithm is multi-class. That means instead of binary, you expect multiple answers. So our digit problem is multi-class classification because we have 10 classes, like 0 to 10. Each digit we can categorize. Out of these 70,000, you ultimately categorize all of them under 10 buckets. So that is a multi-class classification. Is a given image a specific digit? Is this product a book, movie, or clothing? Right? We take a picture of a product and we try to categorize it in three different classes. Is this movie romantic, comedy, documentary, or thriller? So all of these have multi-label data, so that's why it's called multi-classification. Binary and multi-classification actually goes very closely. Binary has only 2, multi has many. Third model is called regression, where you try to find out a value, right? So it's not a predefined classification. What will be the temperature of Colombo tomorrow? So you try to come up with a particular value. Or what will be the price of this product that I can sell, right? So you come to a value. What will be my forecasted inventory for this week? It's a value and it's called a regression model. The other type is called unsupervised, where you don't have data, you don't train your models. So you have algorithms that once you feed data, it can classify or it can identify the relationship between data and group them together. Group data that has similar attributes together, right? So there you don't need this training, extensive training, because you have the algorithm and it will try to figure out the relationship between those different products and group them similarly. Find anomalies in a heap of potatoes, right? So you don't have to feed data into a solution like that, right? You have a heap of potatoes and you feed all the images through a classification algorithm, and it will say, okay, 70% of images fit into one group and other 30% fit into another group. That means there is some kind of anomaly between those two groups. You can define like how many groups you need. If you want to categorize into 10 groups, you can say, okay, I need to categorize this input into 10 groups, so it will break that out into 10 groups based on similarities, right? So if you look at Google News, they also go through all the news and try to find the similarities, and later on, of course, it can find some topics around that as well. Those are unsupervised. Unsupervised models are easy to build because you don't have the training complexity. But sometimes, but it depends on what type of a solution you want to build. So this solution is going to be a supervised learning with multi-class classification. Okay. If you don't follow, let me know. I'm trying to, very simple, right? I mean, nothing major, it's very, very basic stuff. If you don't follow, just let me know. So I prefer all of you, if you have, how many of you have used AWS as a stack? Okay, quite a few you guys have used, right? So in AWS, like having AWS experience will help because you just need to deal with some of these. You don't have to understand all of this, but I advise those who haven't used, have at least a test account, you can experiment with them, right? So this is to set up that environment. What it tells is basically use S3 as a data storage, because in my setup I don't have physical devices, it will be all virtual machines. So I need to store data somewhere, and I tell, okay, use this particular location to store my data as well as the result and the model that you come up with. Once you set that up, it's a matter of training. So this is a tough subject. I am not an expert to teach here. This is kind of a pictorial view of a neural network, how a neural network works. It's basically you have multiple layers, and each layer identifies certain attributes of data. For example, maybe the first layer of this will identify all the edges, right? And that goes as an input to the next layer, and next layer tries to combine them together and try to identify certain portion of that data. Likewise, it goes through multiple layers, and probably the final layer will identify that as a picture of a digit and which picture. So this is kind of a lot of mathematics and statistical algorithms, and there are various algorithms, and we learned those in university times, linear algebra, statistics and all that, but that knowledge is required in order for you to understand this better. But having some knowledge about how neural network works is important, because you need to tune certain parameters of the network to arrive at a good solution. So this is kind of the Python program. Like this Jupyter works in Python. I think it supports other languages as well. Python is a kind of a language of choice for AI based solutions. So I would advise all of you to have some hands-on with Python. It's a very powerful language for data processing, slicing and dicing data and showing the result. You can do a lot of things with Python. I mean, this entire web application can be built using Python. Like you can access HTML elements, draw graphs, things like that, right? So this is basically the algorithm that we're going to use, which has been coded in Python, right? So we have to have this. Then you need to provision hardware and other required infrastructure to build this solution. And there is something called estimator, which is very popular in AI. If you go to if you go through TensorFlow, you find these estimators. It is nothing but a small kind of convenient object which allows you to train this data in distributed environments, right? So if you look at, now we have one data set, but I should be able to process this data using distributed computing, right? So that complexity of distributing this data among multiple nodes and multiple hardware is abstracted away by this estimator class, right? So its properties, if you look at, like we give what is the entry point for our algorithm, which is in Python, Then you can here specify number of instances you want to use for training. I'm using just one because creating these instances take time, and what type of an instance I need to use. So let me, yeah, it ran, so it's just a configuration. Next is the hardest part where you need to train our model. So I have the data pre-processed, and the script actually goes through that and organize data in a way that it can be processed. I didn't go through the script in that detail, but let me train this. So this is going to take a while, and I would like to have a kind of discussions because I also want to rush through all of this. I'm doing a bit fast. If you have any questions, you can ask. This will take about 3 minutes to train 70,000 images, and I could increase that time by having multiple instances, but creating multiple instances take longer than that. Like if you look at to create an EC2 instance, it takes time, right? Did you guys follow through that? I mean, I wanted to make it much simpler as much as possible. That's why I took a popular example as well. If you take a custom-made solution, it will take even longer. So in the meantime, I can tell you how did I get into this editor in AWS, so that you can go home and try it out in your AWS. So you go to this Amazon SageMaker, and here you get what you call notebook instances. Notebook is just a runtime which has the processing power and an editor associated with that, and you can access your AWS resources through your editor, right? You can just create another notebook instance, and this is where the basic program will run, right? For example, I had that Python program. Python program runs in here, and it will actually spawn up another EC2 instance to do the training. And the basic runtime is this notebook. And you can easily create a notebook, very simple. And once you create that, and also you can see the training jobs that you have run through. So you can see all of this. So that's why I felt AWS has like this comprehensive set of tools to experiment with your AI solutions. Any questions? I would like to see like what have you used in Microsoft AI. Have you used any solutions from Microsoft? Like what sort of services? Right. What sort of data you could train? Right. Right. Okay. So you had an algorithm that you could choose to do that. How was the result? How was the result of running that algorithm and predicting the outcome? About 8% accuracy. That's not bad. I mean, with more data, was that a supervised algorithm? Probably it is a supervised algorithm, right? Like you had data and past data, how it worked, kind of a forecasting. Okay. Anyone else who has used AI, even as a service? You have used?
I have done something with machine learning.
Right. What?
Actually, it was done in my imaging project.
Okay. What did you do? Did you build an algorithm?
Sorry?
Did you build an algorithm for machine learning?
I've done with logistic regression, neural networks, and
Okay, great. Anyone else? Anyone has used Google APIs for anything like voice recognition, voice capturing, chatbots? All those are very interesting solutions. So I think training is done. So once training is done, I need to, now I am in the second step, I have trained the model, I need to deploy that. So after training this model, it actually results in a small file with some binary and some configurations, and this model can be deployed in an environment, and you can start predicting the results, and it's called inferences in AI terms. Unfortunately, this is going to take another 5 minutes, because this needs to be deployed in a given kind of EC2 instance, and again it has to create an instance. So in practice, what's going to happen is you have this model, and as you get data from the field, you start training this model. You will have to modify these scripts and do it, and generate the newer model and just deploy it on top of that. So over a period of time, you will see better results. I'm actually trying to show you like how this prediction algorithm works by doing some handwritten digits and see the results. So that's why I thought then it's kind of end to end. You see like all the 3 steps and the results as well, right? Let's wait for another 5 minutes. Yeah, I think there are a lot of applications of AI in your day-to-day product developments. You just need to think through how it can be used. Yeah, so we find a lot of users of that for what we do. Yeah, we can't talk some of those because they are proprietary as well, but I'm sure AI will have a lot of influence in all the businesses. Yes. So training typically, I don't think training happens real time. So what happens is you will do predictions, and there will be some verifications also. For example, if you look at Google Smart Reply, I'm assuming this is what they do, right? You get 3 suggestions for the answer. Thank you, noted, okay, I'll see you later, right? And then they check, did actually user click one of those buttons. If they click, that means it was accurate, and that's the model. If not, there was some problems, right? Likewise, they collect that data, and then again they feed it into the same model, and they train it, and after a while only they probably deploy it. It's not always real time. Training takes, actually this is simpler. Probably this is the shortest time I have spent training a model. For example, if you want to classify images, which is not that accurate, like you get about 70% accuracy or 80% accuracy, it takes 5 hours.
Right. So training and
Deploying doesn't take time. Deployment does not take time. Here just we need to create a new instance of a EC2 instance, which takes time. But if you already had a system, you just have to deploy the model. So you already have the.
So all these 3 activities will run in parallel, it seems.
Yes.
Yeah, execution, deployment, and
deployment you can decide when to do, but deployment doesn't take time.
right.
Training is the only time consuming, which needs to be parallelized, which needs to have proper processing power, whether if you are using TPUs or GPUs or CPU, multiple CPUs.
Correct.
That's why if you don't go for a framework like this, it will be tough in real world situations. So then again, I went through a presentation on TPU, what they're trying to do. So what they're trying to do is, a lot of the CPUs that are out today are precision based, right? They want to calculate up to 20 decimal points number, right? But humans, they don't need that much precision, right? We just need only 2 digits. We always roll it out and we continue. So what they found is, like if you use typical CPUs, they have a lot of unnecessary processing to arrive at an accurate number. So what these TPUs do is, like they try the optimal way to calculate like humans. So that way they can they can use the processing power optimally.
Okay, thank you.
Any more questions?
Yeah.
Can,
I had some experience with the Tesseract framework,
Sorry?
Tesseract Google OCR framework.
Uh-huh.
So, but in this case, I know it's not fully AI based, but a combination of AI plus rule based as well. But
Yeah.
in that case, actually, we need a very small number of samples, like let's say 200 to 300 characters
Okay.
per one. So then,
Right.
but the accuracy is really high. So what's
Right.
the difference? I mean, using this type of thing.
I'm just thinking, what is the use case? Like, what sort of digits you are going to recognize?
It's in my example, I'm using to identify the Sinhala characters.
Mm-hmm.
So, but the number of samples we use like 50 to 100.
Yeah.
But one contains like 200 to 300 characters. So that means like few thousands.
Right.
But the accuracy goes like 90%.
What are the rules you used?
Actually, the Tesseract has the rules in bit. I mean, the rules are pre-written. We just need to identify the character and tell them.
Okay, so
in each sample, we are providing. Yeah, this is simply this is that character.
I'm just thinking, right? If that, if with a small set of data, if you could train that model or get much more accuracy, I'm thinking variation of data is less. And were you considering maybe certain set of handwritten numbers, like maybe your own handwritings or somebody else's? The variations of data may be less, so that it can become more mature.
Actually, it's OCR, not ICR, intelligent character reading. It's optical character recognition.
Yeah.
So then the version.
So could it identify like somebody like who like some character that you have never seen before?
It doesn't work like that.
Yeah, because I'm thinking like there is no magic that I know up to now to identify some of these calculations our brain can do, right? I mean, it just is. There is no any theory behind that, whether how it could be, unless that data set was like confined to a certain set of handwritten digits. Rules can help, but unfortunately I can't see how rules can be applicable in situations like this, because if you look at that digit, 3 is fine, but you can have so many variations of how you write that 3, and it's very difficult. Sorry, I don't have an answer, unless it was a coincidence or like was a set of predefined characters. I think deployment also done. So I enjoy doing this. The reason is after training I want to see my own handwritten digits and see how effectively it can identify, right? So let me see. Sometimes it goes wrong, sometimes it's perfect. So this is one. So this is just for me to see, okay, this is how I interpret this data into numerical values and arrays, matrices. All the mathematical terms we used in universities are useful here. This is where we do the prediction. It could actually identify properly, right? So if you look at this, what I highlight here, this is the answer. With 99% confidence it has given this is 1, right? What you see here is like it will give predictions for all the possibilities. This being 0 is a very low possibility, right? This being 1 is 99, this being 2 is 9.59, again very low possibility, like this is a small number, right, represented in scientific form. 7, yeah, like 7 has a confidence level of 0 something, right? So this model could actually identify a lot of the times, but once in a while it still fails. Yeah, let me see whether it can identify 2. I don't have to run this. Yeah, I mean this model is very kind of perfect. It can identify a lot of data. I've tried and it has passed about 99% of time. Once in a file it can fail, especially because you draw it in a different area of the picture. So this actually covers built-in an AI solution, and any AI solution can be related to a similar setup, right? So let me switch to the other part of my presentation. If you have any questions, let me know. It will work. Let's see. It's a tough one to draw. It came as 5. No, it's 6. Yeah, it could identify. Yeah, I think this model is pretty accurate, I think. That is wrong. It's identified as 3. Mainly because probably the canvas, what I've seen is there is a particular area in the canvas that it takes as compared to the training images. If I draw somewhere else, it considers probably part of that image. Probably it took this, probably like this, right? Predicted it as 3. But let's try. So that's a danger actually. Like if you use AI for any critical problem, it can go wrong. So that's why I think it could identify. Any AI solution still requires some human intervention as well. Hope I was able to give you some sort of understanding about an AI solution. Now I'm going to take you through some of the interesting solutions that I have found, and also we can relate it to a similar implementation. As you know, AI is transforming us even without us knowing, and it will only accelerate in years to come. So one of the areas that's going to be impacted is the accessibility. Accessibility, what I mean is how we communicate with other people, how we communicate with all our devices, computers, and all of that, right? The biggest reason behind this is the advancement in voice and the image recognition, right? So if you look at why do we use a keyboard, primarily because we could not communicate with the computer. So we had a different arrangement so that people can train the keyboard themselves and input data to that. But the most natural way would be to, speak to a computer, right? That would be more natural, right? So with the advancement in voice recognition and even image recognition, even concepts like password, username, all those can go away in years to come, and it will be able to identify people most natural way by looking at the face and all of that, right? And also I feel a lot of the applications we have today will be reimagined in a way like you won't have the concepts of even touch-based solutions, because you can always speak to a computer or your, let's say, your smartphone. Why do you need to tap on each of the applications and scroll through? If you can just tell the smartphone to, okay, can you transfer 5,000 rupees from my HSBC account to HNB account, right? I mean, that's so simple. You don't have to go through any of these steps. If the system can recognize your voice, it's extremely powerful. And also, if you know, probably you guys know some of this, Google can today identify about 120 languages accurately, and including Sinhala, which is spoken by just 20 million people, right? So you can see how powerful these tools are going to be. So what it means is people who are not able to use these devices will be able to use them, right? And irrespective of the age and how you could be trained on using these devices will try to respond to the natural way of working with them. So it will go to every nook and corner of the world with these capabilities. Because even an elderly person can start using a smartphone, right? Today it's not possible. Today, because of English language barrier, people can't use some of the features and applications in the phone, right? So having native support is extremely important, and I think Google is investing heavily on that, and they always think all these solutions should be available in native languages, right? And it will only start growing, and even conversational application, as I said, will become more and more popular. And many of the products are already being thought through this AI and how they can be enhanced. Google actually, if you went through I/O 2018 presentation by Sundar Pichai, they showed this duplex, which is very powerful tool where you can simulate a human in voice, right? So you can talk to a real world person through a machine, and that person cannot identify whether it's a machine or a real person, right? So it can do voice recognition, voice generation. That is also not a simple thing, right? I mean, if you ask for your Mobitel balance today, you know, how would it speak? You have 2,550 cents, right? I mean, it's not easy to generate natural voices, because there's a lot of things about, you know, how to make a voice natural. I think Google is investing heavily on this. So this is a sample that I
Good evening.
took.
Hello?
Lady is
Hello.
a real person.
Hi, I'd like to reserve a table for Friday the 3rd.
Okay, hold on one moment.
Mm-hmm.
Okay. Hold on one second. So Friday, November 3rd. How many people?
For 2 people.
2 people?
Yeah.
What time?
At 5 p.m.
Okay. And your name?
The first name is Daniel. That's Daniel.
Okay. You're all set.
Okay, great. Thanks.
We'll see you next Friday. Okay, thank you. Bye.
So
Goodbye.
So probably the lady on the other side of the conversation did not know it was a bot talking to her, right? I mean, it's advancing in that level, which means like even when you go to a restaurant, probably instead of a waiter, you may have an automated bot talking to you, because it can understand and talk very natural way. And look at the complexity, like you have to pause and you repeat, you try to grab what other person is telling, and there is a lot of context with that conversation. So Google's technology is able to capture that, and these services will be available for most of us. I'm hoping they will open source some of these or provide them as services. Another area AI is transforming is healthcare. Probably you may have already heard of some of the amazing solutions in healthcare. So I have taken 2 examples that I'll quickly go through. Why healthcare is being transformed is mainly because AI is able to process huge amount of data and also, you know, identify the patterns, right? Today, I think in medical field, you have access to data, but there is no way to process. With the advancement in this, they can process data in a record time and identify more insights from data, right? Because more data means you can identify variations. I'll have one example where when doctors use about 7 data points, AI can use about 10,000 data points of that same test and predict much better. And we'll be able to have more non-invasive way to treat people without damaging our bodies and taking our blood and all of that, because there may be other data that we can use to predict certain conditions of our health, and prioritizing treatment based on criticality. and periodical and predicting some of the critical medical events in your life based on past data. So you know upfront whether you are at risk, so you can take more. So these are not just imaginary; they are already in the field. It hasn't gone into the general public yet, but I'm sure it will come to even countries like us and hospitals in our region as well. It's still at the early stages because they need to spend a lot of time, but it's very promising. And also avoid error due to human fatigue and negligence. Doctors just can't. If a doctor has to do 50 operations a day, you don't know who will be the culprit on that day. Right? So we have gone through some of those complications in the past as well. I personally went through some mistakes, probably because he was not fit enough to do the operation. So those errors could be definitely avoided. And one of the biggest advantage out of all of that is, I think, for us to see more transparency about what the doctor prescribes and how he does it, and whether that's the right way, because more than the doctor, it will be machines who will decide on that, and we will have much more transparency, right? So patients will have much more say about, whether that treatment is right for me and what is the outcome of that treatment. So all these will become a possibility. So this is one example I just took from Intel AI, where they try to identify the difference between what we call pericarditis is a symptom of the heart, like it feels like a heart attack, like a cardiomyopathy, which is related to a heart attack. So identifying the difference between these two has been extremely difficult, because you get the same symptoms, and only experienced doctors were able to identify this with about 75% accuracy based on the data, and inexperienced doctor probably would make 50% accuracy. So it's like tossing it, right? So in general, with doctors' ability to analyze it, 57% of accuracy they can achieve, because they have about 7 points of data to analyze from ECR and all the other tests that you do. This solution is able to identify that with 90% accuracy, right? And they are able to capture 10,000 attributes of heart within a single pulse. Right? Look at the amount of data that we get without us even knowing. Human can't do that, right? And for that solution, they have just used 50 pericarditis patients' data and 45 patients with heart problems, and they've been able to get 90% accuracy. But we have a lot more data, so I'm sure it can go even beyond that. And probably they probably use kind of a supervised learning algorithm as well, because you have patient's data and what type of complication he has. Based on that, you can easily train. And this is again from Google, where they're trying to identify cause for blindness in diabetic patients, right? Retinopathy is the main cause of blindness for a diabetic patient, and they are able to identify that upfront. So what's more interesting is, as they were doing this experimentation, they were able to identify more insights from data, right? They could identify whether the person was smoking, the age, the biological sex, female or male, even the blood sugar level, which is like 3 months average, A1C, BMI, and blood pressure as well. See the amount of data that we never knew earlier, right? So with this, they can identify a lot of other things without even touching the body of the patient. And they're thinking they will be able to predict cardiovascular risks, which is a risk associated with your heart, 5 years before the actual event takes place, right? So with that, they'll be able to do more non-invasive way of precautionary measures and treatments. So these are they actually trying this with two hospitals in India, and I'm sure this will go into more other places in the world. And food production, this is related to what we do. That's why I took one slide on that. So today we don't produce enough foods actually. Even today, for some of the other countries, we do have ample foods here. But in 2050, UN is predicting there'll be about 50% more demand for food, right? And producing this food is very challenging with the limited amount of resources we have, right? All the natural resources are being depleted rapidly. So this solution I took because it's very simple. If you look at, they were trying to fix the problem of one cow milking 30 liters versus another cow milking just 10 liters, which is related to health conditions of that cow. In a field, you can't identify like which cow is having these health problems because you can't keep on monitoring, right? So what they did was they attached a small sensor in the cow's neck so that we can identify the movement of the cow or the cow's neck, which actually can figure out what is the activity that cow is doing, right? Those activities are related to their health. Their health or activities are reflective of their health conditions, right? What is interesting about this solution is like how we think through a particular problem, right? And how do we apply these concepts to come up with a creative solution. And this was an early startup about a year before when I did this study, but now they have gone into production and commercial product. So with this, they are able to do cows having figure out digestive disorders and lameness, and who are better suited for breeding the next generation of cows. Yeah, and even when a cow is expecting to calve, right? I mean, those are things that you can find from this information. And combating world poverty. So this is an effort by, again, UN. One of their challenges is to actually reach out the poorest people in the world, especially in African countries and even in India, I think, in large continents like that. Reaching to those needy people has been extremely difficult because they don't have enough data, and they don't have surveys, or there is corruption, so you don't actually get to see who are the poorest people in the world. So they are partnering with some of the universities to see through satellite images whether they can identify the areas where they need the donations to go, right? So they are planning to get a world poverty map. So that can be useful for a lot of charity organizations. So why I had these two diagrams or pictures is mainly because so that is, even today Google can identify that area as a slum area that requires some sort of donations, etc. And this as a urban area. So this is a picture from US Austin, and that is one of the cities in India. So I mean, these are technologies available today, right? Not things that are imaginary. So there's a huge possibility for us to use the solutions in multiple ways. I have taken very few examples. Transportation, I'll cover very quickly because we are running past time as well, is going to change our society tremendously, probably in next decade, right? With all the autonomous cars coming into the roads, and because it will only continue to grow, and when we have more and more autonomous cars, the risk of mixing autonomous cars versus man-driven cars will be lesser and lesser, and people probably will not even own their cars, and it will be available probably as a service. And people will start living in outskirts, so that this urban living and all that can change. So probably next 2 decades we will see a lot of these changes happening. And also Google is using this to save power, and there are a lot more products. So what Google does is, like, based on the data center behaviors, they can predict the power consumption to cool their data centers, right? So that way, so this diagram shows when we don't have AI solution, what is the power usage, which is like very consistent, like the high power usage. And when you have the machine learn based algorithm control, you can see the power consumption changes, right? So this is the power required to cool down your data centers, which is related to the usage of that data center. The more people access data, more hard disk will run, and that system will heat up, right? So very creative way of thinking. So that's I think what we also need to do. And at the same time, we will have negative impacts. So Pul was telling me, like, there was an incident where server to server, they have autonomously done something which is perfectly possible nowadays. Like they can talk to devices can talk to each other without any human intervention, and they can initiate their own activities, own actions. So that's the danger with AI. AI being used in warfare will be a huge threat. With unmanned vehicles and all of that, we will not have suicide bombers. Instead, it will be just autonomous systems, cars, drones, etc. And also, I think the biggest problem is if you rely on an AI system to make critical decisions, even in a war-like situations, because today at least people will think twice, so they will have much more control. If you offload that to an entirely automated system, we just don't know what will happen. And the good news is, like, I figured out 2 incidents where one incident is Google. They are going to discontinue one of the engagements with Pentagon, where Pentagon wanted to analyze satellite drone images to analyze the ground situation. But later on they have thought, okay, this can be used in war-like situation, and because of that Google is discontinuing that contract because they don't want to use AI in battlefield, right? So those are good signs. And another next incident is South Korean university partnering with a company who builds armaments, right, to build an autonomous robot. So that university was boycotted by a lot of universities around the world. So they are in a bit of a problem. But things like this will definitely happen, right? So we just can't stop that happening. People will learn AI, and there will be enough infrastructure to do various things, and that will be a huge negative impact. Again, security-based AI or security of AI-based solution is going to be a huge threat. Because today you use physical data, and accessing that data is hard. Getting into this building is hard by bypassing the security officer down there, right? Likewise, I mean, that's a small example. Similar way, today there is a lot of barriers to access some of the critical systems, right? But if you digitize all of that, there can be a lot more loopholes where people are able to generate data and inject data through the networks, which is completely invisible and can create a huge damage. So that's a huge threat. And also bugs in software that can cause even fatal problems, right? Even, like, I think there have been situations even in autonomous cars. And Volkswagen, they had a problem where a developer had injected some code for green testing, and after years only they found out, okay, their testing results was not right. I mean, that's a small problem, but similar problems can happen negatively. Next big impact is about our jobs, and jobs people do today, and how do we employ our people with a lot of these automations, especially with related to 4th industrial revolution, which is around AI and IoT and a lot of robotics work. How we are going to employ people who lose their employment. So this is a survey done by McKinsey, and they predict there will be about 800 million people being replaced or displaced due to the automations. The countries affected by them would be largely US, China, and India, and other, like, surface area denotes the number of people will be affected. So by 2030, they expect about 800 million people will have some problems. Do you have to be what we call Luddites? Luddites are like people who actually oppose textile industry when it was automated in late 19th century. So they started sabotaging all the automation plants related to textile. And this was a very popular case because they oppose automation. So I don't think we have to be like Luddites because what that industrial revolution told us is like, okay, initially we see a threat, but over a period of time, people will figure out creative ways to employ the world population. And in early 19th century, most of the jobs were agriculture, manufacturing, and mining, and they have depleted. That today we have a lot more other areas because people increase their income and they have more creative ways to do things. So I don't think there is a huge threat, even though 800 million people will see changes in their jobs, etc. And the same report actually predicts there will be increase in the jobs as well because of the rising income and people having more time to come up with creative solutions. So around that there will be new jobs being created. So as per this report, there is no huge threat, even though 800 million jobs will be displaced. That doesn't mean they will lose jobs. They will have to upskill their knowledge, or they will have to adapt to new situations. Right? And also they predict by 2030 there will be a lot of old people in the society, and they will require special attention. And around that, so if you look at this one, 50 to 85 million jobs are due to age in healthcare. Right, so it's going to be a huge problem. Actually, in previous diagram, like Japan is going to have the huge problem. This color says people in Japan will be above 45 years of age by 2030. So the report predicts, which I also go by that, there will be new jobs being generated as well to offset the jobs that will be lost. I think that brings me to the end of the slide. I just wanted to share this video from Bill Gates. Robots should be taxed like humans.
So I just created this dope website with Wix. Let me show you how I did it. First up, go to...
Right now, if a human worker does $50,000 worth of work in a factory, that income is taxed. If a robot comes in to do the same thing, you'd think that we'd tax the robot at a similar level. What the world wants is to take this opportunity to make all the goods and services we have today and free up labor, let us do a better job of reaching out to the elderly, having smaller class size, helping kids with special needs. All of those are things where human empathy and understanding are still...
See the video, you can't see, right?
...shortage of people to help out there. And so if you can take the labor that used to do the thing automation with the factory, that income is taxed. If a robot comes in to do the same thing, you'd think that we'd tax the robot at a similar level. What the world wants is to take this opportunity to make all the goods and services we have today and free up labor, let us do a better job of reaching out to the elderly, having smaller class size, helping kids with special needs. All of those are things where human empathy and understanding are still very, very unique, and we still deal with an immense shortage of people to help out there. And so if you can take the labor that used to do the thing automation replaces, and both financially and training-wise and fulfillment-wise, have that person go off and do these other things, you're net ahead. But you can't just give up that income tax because that's part of how you've been funding that level of human workers. Some of it can come on the profits that are generated by the labor saving efficiency there. Some of it can come directly in some type of robot tax. I don't think the robot companies are going to be outraged that there might be a tax. It's okay.
So, yeah, as he says correctly, probably people need a lot more attention and people are getting aged. So we need to fund those things, so that's why even robots should be taxed.
Going on a date to watch a movie.
Yeah, so that brings my presentation to an end. If you have any questions, we can just discuss. And by the way, thank you very much for your patience. It took about 1.5 hours, a little bit longer than I thought, because I did some crazy practical example as well. But I hope I was able to give something out for you to try out in your day-to-day, activities and in development and building your solutions. Yeah, if you have any questions, we can take them.